In this video, we will solve multi-step literal equations for a given variable. The steps to solve literal equations are: first, identify the variable that we're solving for, identify the operations that are performed on that variable, and then undo those operations in reverse order of operations. So remember, order of operations is GEM-DOS, so we're going to be doing GEM-DOS in reverse. So instead of doing grouping first, we're going to do addition and subtraction first to undo those operations. Okay, so we have this equation here. We're going to be solving this equation for x in terms of y. What that means is we're going to end up with x equals, and whatever it's equal to is going to have a y in it. So we're going to use this graphic organizer to help us organize our thinking for following those steps. So far we've identified the variable we're solving for. That was step 1. Step 2 was to figure out what happened to x in this equation. So identify the operations that are happening to x right now. So x is getting multiplied by 2, and when we do that, we get 2x. Notice it's really starting to look like the equation. Well, what else happened to the 2x? Well, we added y to it, and we have 2x plus y. Those are the operations that happen to x on this side of the equal sign. So having the 2x plus y look exactly like this 2x plus y is our goal. And that's how we know we can stop making boxes, is when the last box on the top looks like our equation. We know that the 2x plus y is equal to 180. So now we can start moving to the bottom, and we can undo all of those operations that happened in the top. Remember, we're working in reverse order. Notice the arrows. We started here, moving in this flow and going down, and now notice the arrows are going back the other way. So how do we undo plus y? We undo that with minus y. So 180 minus y is our first step in undoing those operations. The next operation we had to undo was multiplication by 2. We undo multiplication with division. So I'm going to divide everything from the previous box by 2. So the 180 minus y is divided by 2. This tells me once I've undone all of those operations, this last box on the bottom tells me what x is equal to. So x is equal to 180 minus y over 2. So now let's take a look at doing this purely algebraically. Remember, we're going in reverse order of operations. So order of operations is GEM-DOS. So we're going to start at the end with addition and subtraction. So we're going to undo the addition first. So we're going to subtract y from both sides, and we end up with 2x is equal to 180 minus y. If you look back at that middle step here, we had 2x is equal to 180 minus y. So those steps here match what we did in the diagram. Now we need to undo that multiplication. So we're going to divide by 2 on both sides and be left with x is equal to 180 minus y over 2. Next, we have s is equal to 4 pi r squared. We're solving this equation for r in terms of s and pi. Remember, the in terms of just means that's what's going to be on the other side of the equal sign. We're going to have r by itself, and we're going to have an s and pi on the other side. Okay, so we're solving for r. So we have to figure out what happened to r. Well, first, r was squared. So r squared is what we have here. Next, we multiplied r by 4 pi. So we have 4 pi r squared. We know we can stop making boxes when this looks like the equation here. So we know we're done making the top. So now we can start with the bottom. So 4 pi r squared was equal to s. To undo multiplication by 4 pi, we're going to divide by 4 pi. So s is divided by 4 pi. To undo a square, we have to square root. The thing that we're square rooting is this s over 4 pi. So we've now undone all of the operations from the top, and what we've ended up with is r is equal to the square root of s divided by 4 pi. Okay, let's look at this algebraically. Algebraically, we need to divide by 4 pi first, because we've identified that multiplication would come before the exponents in reverse order of operations. Then we end up with r squared equals s over 4 pi, and we have to square root both sides, so that r is equal to the square root of s over 4 pi. Notice how, once again, each of these steps match what we put in the diagram. These next two problems are on your own. I'd like you to draw the diagram. Remember, what goes on top are what you're doing to the variable, and then what goes on bottom is what you're undoing. Then I want you to practice doing this algebraically. For the next example, once again, start with the variable you're solving for and figure out what operations happened. Then undo those operations on the bottom. And then work this problem purely algebraically.